Hi, I'm Toby Kaplan. For more than 30 years, I was a classroom teacher and a mathematics coach. Now I get to work with Symphony Math. We're going to look at a routine that will take 15 or 20 minutes of your class time. It's a routine that you can use with the whole class, a small group, one-on-one. You can use it remotely, and it works for every Symphony Math task. Today's materials will be, I made the number bars, which are similar to the bars we see in Symphony Math, and you'll notice since we're working only to 5 that I made my bars of one color, the 5 bars of one color. I've got the number cards, the equal sign, and the subtraction sign, which I downloaded from the Symphony Math support page. And I also use the environment I see on Symphony Math with bars so that it will help students understand that subtraction also means the part taken away from the whole and what is left over. We are looking at stage 3.3, subtraction, missing results to 5. In addition to working with their fluency and the number combinations to 5, we're looking at subtraction as taking one part away from a whole. Students are used to combining parts to make the larger whole. And sometimes subtraction throws them because they're really not sure which is the part and which is the whole. Additionally, by using the bar model, we're implying a comparison, which is another way of thinking about subtraction. You can find more about parts to whole and subtraction in the stage overview, stage 3, in your Symphony Math support page. We're used to putting parts together to make a whole. Today, though, we're going to be looking at subtraction, and we're going to take a part away from a whole. I see here that there's a 3 bar. That's my whole because it's labeled whole. This tells me the part that I'm going to take away from the whole, which is 3. If I take 2 away from my whole, I can see there's 1 left over. I'm going to put my 1 cube here because it's got to be the same as this 1. So I can see that 3 with 2 taken away leaves me with 1. What do you notice? What do you wonder about? Asking students to notice and wonder asks them to stop, not talk, but just do some thinking. After a few seconds of allowing them to think to themselves, listen to their ideas. Now, students might remark on the colors, and that's okay. It may take them a while to get to some mathematical things that they're wondering and noticing. But really, there's nothing wrong with what they say. They can't make a mistake. It's a safe place to do some talking. You can prompt them if their comments are more about color and not about math. You might say, if somebody said, well, the whole was all orange, you might ask them, well, I wonder why that 3 bar was only orange and no other color. And why was the 2 bar a different color? We're going to make a number sentence that matches this model. I can see that the whole is 3. I'm going to put my 3 here. The part I take away is 2. I know that when I take away, I need this sign, it's a minus sign, and I'm taking away 2. The part left over equals 1. So if we start with 3, and we take 2 away, we are left with 1. I see the ones match up. Mathematicians love to take shortcuts, so they use quick words. They would say 3 minus 2 equals 1. And since you're mathematicians, we're going to say 3 minus 2 equals 1. What do you notice? What do you wonder about? Have students do this noticing, wondering quietly in their head before they share their ideas. Again, if their comments are not about mathematics but more about colors or something, then give them some prompts and don't judge them, don't correct them. Just let them talk. You can ask them things like, how does the model help you solve a subtraction problem? How does this model show you the part that's left over? Students will often see things and say things before we have to tell them. You can do a second example with your students. This problem looks different. Now I see that the equal sign comes to the front of the problem, and it's still a subtraction problem. I'm going to make a model that matches this number sentence. Watch me. Well, I don't know how much is left over, but I can see that I'm going to start with 4. 4 is the whole amount. I can see I'm going to take away a part, and the part I'm going to take away is 1. Well, if I take 1 away from 4, then I can see I have 3 left over. I want to make sure this part is correct. I started with 4, I took 1 away, and there were 3 left over, and these match. Now, if I look at the way this number sentence is, though, I'm still looking for the leftover part, and I see it's 3. So I can substitute this number and say 3 equals 4 minus 1. 3 equals 4 minus 1. This problem may throw them because the equal sign comes to the front of the number sentence. It still is taking one part away from the whole and looking to see what is left over. You might prompt them. You can ask them questions like, well, how did the bar model help you find the missing part? Did it matter that the missing part was at the beginning of the number sentence? Are the parts in the whole still the same no matter where that missing part appears? Students, as they speak, might end up surprising you. They may be able to understand parts, whole, and they may throw in words like addition and subtraction. They may understand there's a connection. They may talk about the equal sign and the minus sign, and if they don't, call their attention to that. You can say to students that you have faith that they can work on some problems on their own. You can find many problems. If you go to the guided practice, stage 3.3, you can go to the demo mode and project problems from stage 3.3 on your smartboard. And you can download the Symphony Math Checkpoint page, stage 3, and fill in the numbers you would like the students to work on. When students are working on their own for 10 minutes or so, make sure you're listening to the comments and the actions they take with their cubes and what they have to say to each other and how they show that their answers make sense. This will help guide you. It'll help you decide which students you might want to call on to share their ideas. And don't be afraid to call on students who might make an error. As students try to justify their solutions, they stumble when they try and make a model of their thinking, and they often correct themselves. That helps you in turn model that making a mistake is a fine thing to do. You can have a positive reaction to a mistake because we know many students get upset when they make mistakes. When they're done, here are some questions you can ask them. Is using a bar model helpful in math for addition as well as subtraction? What did you think when you saw the equal sign come at the end of the number sentence and when it came at the beginning of the number sentence? How are problems like these the same? And how are they different? How could you identify the parts? And how did you identify the whole? You did a good job of having a challenge, making models, sharing your ideas, and working through problems that might have stumped you. Our brains like it when we have problems because it helps our brains think of ways to solve problems. As you continue, students can then go back onto Symphony Math Stage 3.3 and you can watch their progress. Your dashboard will show you in red who is still struggling. These are students who may benefit from more offline work, where the other students might be ready to tackle the very important ideas of subtraction. Addition and subtraction are critical ideas in grades K to 2.